Hey guys, we're going to quickly go over what we did last week, and mainly we dealt with exponential functions, word problems, all that good stuff. So let's get started. I'm gonna go ahead and go straight. I'm on page 1 of our packet. Just briefly look at this little image on the bottom. This tells us what an exponential function should look like. The red graphs and the blue graphs are all exponential functions, okay? So notice that it curves a little bit. It's not a straight line, right? A straight line would be a linear function, but notice how our exponential function is a little curvy. It is also not a quadratic function because a quadratic function is U-shaped, all right? So it doesn't swing back up or swing down on both sides. It just goes up on one side, but not straight. Okay, so let's go ahead and see if we can do some problems together. We use a table to graph exponential functions. You can find the y values by raising the base to different values of x. In general, the domain and range for exponential functions are, and this is in general, okay? It's going to be x is greater than or equal to 0, and y, sorry, I was mixing that up with something else. Our domain is going to be all real numbers. And then our range is the one that is going to be y is greater than or equal to 0. Let's go ahead and see if we can graph these. Remember, we graph them all the same way. Any time we have a graph, we need to graph. What we want to do is we want to go to y equals. So I have my calculator open. Going to go to y equals, clear what I have, and let's put 2 to the x power. To get the exponent, you're going to press this little key. Looks like this. That's how we get exponent. It's on top of the division symbol. So 2 to the x power. And then I'm going to press second graph to get our table of values. All right, and let's only write down the ones that we can graph. So notice I get decimals over there, so I'm not going to write them down. Let me just go ahead and write down our whole numbers. 0 gives us 1. 1 gives us 2, 3 gives us 8, and that's as far as we can go because 4 will give us 16. That is not on my graph, so let's graph these. 0 gives us 1, 1 gives us 2, 3 gives us 8. So now when you're thinking about how to connect these points, a really smart thing to do was just press the graph button so you can visualize what the graph is supposed to look like. So I know my graph is supposed to look like that. Let's make sure I can emulate that on my paper. It curves up, maybe a little bit more over, like that. And then notice on the left side, right, our line is going to go all the way down, but notice it does not pass the x-axis. Okay, it does not pass the x-axis. This is an example of exponential growth. As we look from left to right, the graph is growing. The equation for an exponential growth has a b value that is greater than 0. Okay, but we just know that in order to graph our exponential functions, we create a table of values. Let us move on. I'm now going to jump all the way down to page 4 when we dealt with exponential word problems. Okay, keywords for exponential growth would be growth, or growing, or grown. We have increase. And then this last one is really, really important. We do see it a lot in our real world problems. It is interest. For exponential decay, we have keywords to look for are decay or decrease. So when we're doing word problems, you are looking for these keywords in order to determine whether it's an exponential growth or an exponential decay. Okay, there is a formula we have to memorize. If you go ahead and join me on page 5. The formula is up here for us. Again, we have to memorize it. It's not going to be given to us. The more we practice it, the better we'll be at memorizing it. A stands for our initial amount. R stands for our rate, okay? In order to find our rate, you have to take the percent and divide it by 100. Might be a little confusing right now, but we'll deal with that. In our formula, we have a plus and a minus symbol. For growth, we're going to be using plus. For decay, we're going to use minus. And X is the time that has passed, okay? And that's usually in years. Let's go ahead and see if we can do example 2 together. Suppose the population of deer in a region was 3,500 in the year 2000. Since then, the population has grown by 3.5% annually. That's one of my key words. Grown means that this is going to be exponential growth. Okay, if it's exponential growth, we are using the formula y equals to a times 1 plus r to the x power. What will be the approximate population in the year 2020? Let's identify our variables. A is our initial amount. In this case, our initial amount was 3,500. R is our percent divided by 100. So I have 3.5%. I need to divide that by 100. Let's use our calculator. 3.5 divided by 100 is 0.035. And X is the time that has passed in years. We went from the year 2000 to the year 2020. So that would be 20 years. Now that I have all this information, all we need to do is plug it into our equation. So y equals, our A is 3,500 times 1 plus our R value is 0.035 to the 20th power. Something I like to do is I always like to combine inside our parentheses first. So 1 plus 0.035. And I get 1.035 to the 20th power. This is a really good check that we're in the right place, because if we're doing exponential growth, this number should be greater than 1. And it is. Okay, so let's go ahead and finish this. Y equals to 3,500, parentheses 1.035 to the 20th power. And let me just write down this number first, and then we'll talk about what to do. 6964.2610, and so on. If we're talking about population of deer, we should not have a decimal number. It does not make sense for me to say there is 6,964.2610 deers, okay? So we're going to round to the nearest whole number. So we're trying to round this 4. In order to round to 4, we're going to look at the number afterwards. That's a 2, so we're going to stay the same. So we're going to have 6,964 deers. Okay, let's go ahead and do example 3 together. You can go ahead and try to do it on your own as we're walking through this together. Adrienne invested $2,000 in an account at a 2.25% interest rate compounded annually. She made no deposits or withdrawals on the account for 4 years. Determine to the nearest dollar the balance in the account after 4 years. Here's one of our key words. Invested. Okay, invested wasn't it? I meant interest. Interest. Interest is a key word for growth. So I'm highlighting it, I'm circling it, I'm writing it. Since this is exponential growth, we're using y equals a times 1 plus r to the x power. Let's identify our values. A is our initial amount. Okay, so in that case, that was $2,000. That's how much money I'm starting off with. R is going to be our percent. 2.25% divided by 100. So again, we're going to use our calculator. 2.25 divided by 100. I know a lot of us like to just move the decimal, but I do urge you to try to use the calculator just to check your work. And X is the time in years, and this one says 4 years. So let's go ahead and plug into our equation. Y equals, our A is 2,000. This is going to be 1 plus 0.0225 to the 4th power. I'm going to combine the inside of that parentheses again. And since it's exponential growth, our number inside the parentheses should be greater than 1. 1.0225, and it is. To the 4th power, let's go ahead and put this whole thing in our calculator. 2000, parentheses 1.0225 to the 4th power. And I get 2186.1666, and then 3, and so on. Again, we have to round, right? Let's read the question. It says determine to the nearest dollar. So the nearest dollar, this is my dollars place. So again, I'm going to look at the number afterwards. The number afterwards is a 1. That tells me we're going to stay the same. So $2,186 is our final answer. Let's do one more word problem together. Example 4. The value of a car purchased for $20,000 decreases at a rate of 12% per year. What will be the value of the car to the nearest cent after 5 years? So here's my keyword. It was already underlined for us, but I'm going to highlight it and I'm going to circle it. Decreases means this is going to be decay. So the formula we're going to use for this one is y equals a times 1 minus r to the x power. Our a value is our initial value, that is 20,000. Our r is going to be our percent divided by 100. So I have 12% in this case. We're going to divide by 100. Let's use our calculator. 12, divided by 100. I get 0.12. And our x is the time in years. In this case, it is 5 years. Go ahead and let's plug into our equation. Y equals to 20,000. And then in parentheses, 1 minus 0.12, close parentheses, to our 5th power. Let's go ahead and simplify the parentheses. Since this is exponential decay, inside our parentheses should be less than 1. So 0.88 to the 5th power. Let's go ahead and put this whole thing into our calculator. 20,000, parentheses 0.88 to the 5th power. And I get 10,554.6383. All right, let's work on our rounding. If I want to round to the nearest cent, our nearest cent is this place value right here. That's our 3. The number afterwards is an 8. That tells us to round up. So I'm going to get $10,554.64 is our final answer. Okay, we should be pretty good at word problems. On the next page, remember there are more examples. You guys can go ahead and try those, but let us move forward. I just want to focus on this one word problem, this multiple choice question over here, and a multiple choice strategy we can use on our regions or any test moving forward. So, Crystal was given $3,000 when she turned 2 years old. Her parents invested it at a 2% interest rate compounded annually. So the first thing I know is that this is going to be a growth. So hold on to that. No deposits or withdrawals were made. Which expression can be used to determine how much money Crystal had in the account when she turned 18? So since this is growth, I know that we should be using plus. That means I can eliminate answer choices 2 and 4 because they both use minus. Let's go ahead and see if we can look at the difference between answer choice 1 and 3. The 3,000 is the same, the 1 is the same, the plus is the same, the 0.02 is the same. So the only thing that's different is the 16 and the 18. Since that is our exponent and that represents our time in years, we just need to figure out how much time has passed. And they purposely try to confuse you. She was 2 years old when she invested the money. She's now 18. So our x, which is the amount of time that has passed, is 18 minus 2, which is 16. So this one would actually be answer choice 1. Okay, be careful with the multiple choice answers. Okay, almost there. Let's take a look. Let's keep going. Let's go to page 9. Whoops, I still have some work from before. I want to make sure we go through these problems together. All right, let's take a look at page 9. We're now going to graph square root functions, and we do them the same way we graph exponential functions. First step, go to y equals, and let's plug this in. If you're looking for the square root function, you're going to press second, x squared. So second, x squared, you get the square root function. I'm going to put in x. And let's go ahead and look at our table of values. I'm going to, look at something really interesting happens over here. We get an error, which is not something we've ever gotten before. We'll talk about that in a little bit. Let's go ahead and graph what we can. 0 gives us 0. 1 gives us 1. 4 gives us 2. Let's see if there's any other numbers I can graph. 9 gives us 3. And then that's it, right? Because we go to 10 and then 11 is off our graph. So let's graph these. 0, 0. 1 is 1. 4 is 2. 9 is 3. Before we connect our points, let's look at the shape of the graph and see how our graph should look, okay? So I'm going to press graph. And our graph should look like that. So let's just connect our points so that it matches what we have on our calculator. Now, we are going to have an arrow on the right side. However, there is no arrow on the left side, okay? Remember, we kept getting errors on the other end of our table. Okay, this is the graph of a square root function. Our domain, okay, we're going to use our table to help us. The first value we could use was 0, 0. Remember, if we try to go to the negative numbers, it didn't work, right? We kept getting error. So, for our domain, it's going to be x is greater than or equal to 0 because all our x values have to be greater than that and our y values as well. You guys can go ahead and try this next you try on your own, but we're going to graph one more function together, which is a cube root function. We're going to do it the same way. We just need to learn where that cube root button is. It is going to be under math. And it is the fourth one. All right, the fourth one has this. Okay, so let's go to y equals and let's try to graph this one. Go to math, press number 4, and I'm going to put x inside, and let's get our table of values. We don't get any errors, which is great. So let's write down all the values that we can plot. -8, -2. -1, -1, 0, 0, 1, 1, 8, 2. I'm going to plot these and then don't connect them yet. -8, -2, -1, -1, 0, 0, 1, 1, and 8, 2. Please use your calculator to look at the graph so you can see what it's supposed to look like when you graph it. Supposed to look like that, so let's make our graph look like that. It's basically like having two square root functions. Notice in this one we didn't get any errors, so we're going to have arrows on both sides. My graph looks pretty good. Let's see if we can do the domain and range. If there are no errors, then our domain is going to be all real numbers. And same goes for our y. Since our y value can be anything, our range will also be all real numbers. Okay, that is all for our practice. Remember that you can always do all the other problems that I didn't do in this video. We did do them together in class. Please try them. If you have any questions, you can comment it here. You can message me on Google Classroom. You can text me on Remind. You can ask me in person. Okay, I appreciate you guys for watching. Have a really good day.